Hi everyone, in this application we are creating an e-commerce application to mimic the real world scenario. Then we are going to collect the data from the platform based on the user order, demand, search history, and based on the data we have, we are going to create an AI/ML model to predict the demand and forecast the logistic requirement based on the historical data from the application. So here we are developing a model to identify and analyze factors influencing demand in logistic industry. So here we have created our e-commerce application, and then we are creating a model, and then we are going to share those data with our logistic partner to help them up and down their logistic requirement needs. So here first step, we are creating that e-commerce application that is going to gather our data. On the second step, right, we are creating a model. So to create a model, you have to take in few requirements, such as like what factors is influencing the demands. So in case the demand from our e-commerce application is more, automatically logistic requirement will also increase. We also have to create data. So we have using historical sales data and demand data. Also with that data, some of the microeconomic data. So when the economy is performing well, automatically demand is also increasing. Then we are going to process the data. Then we are going to select model selection. So based on that, we are using SVM, XGBoost, LightGBM, some of the random forest. We have used we have used transformer to see which model is giving the best output. So as of now, for me, the XGBoost gave a better performance. And now we are using the model training and validation, then model evaluation, then deployment and monitoring, and then continuous improvement. Now once coming that, and based on those, right, it is going to help us to improve our inventory management, enhance supply chain planning, and a lot of other things that is going to help us in our e-commerce application. Now if I look into the demand forecasting, we have used an Walmart data, and based on it, right, so based on which user are purchasing more information. So first you're doing a general based on age, which people are buying the products more, whatever products are getting sold. So different type of distribution we have taken into consideration. Now we have taken all those information, and based on that we have created different models. So if I come down into this notebook, so here we have splitted it. We have created linear regression model, some of the other models that we have created, some of the decision tree model, and we are generating this code based on that. So now when come to then we have taken another application or another use case. So here we have taken this information from Walmart, and based on the different parameters, for example, store ID, other information such as is it a holiday, or let's say is it a Super Bowl, Thanksgiving, or Christmas, or what is the demand, what is the general demand on those days, what is the general cost, or what is the general demand on different dates, what is the weekly sale in the festival season, is the sales increasing. So different type of matrices we have done. What are the different sales by different departments, what is the cost, in which year the sales was higher, and we have taken all those. We have also created some of the information. For example, here, right, we have taken we have plotted a graph based on the fuel price based on holiday, right, how our demand is getting influenced, and getting all those information, right, we are creating models, time series models, and predicting, right, what would be the rolling average or next weekly sales based on those information. So we're creating all those models, and we are creating all those time series information. Not only that, we have also created for our logistic requirement, we have created and taken the dataset from the delivery app, which is a very common application. I also tried to reach out to the Sri Maruti, but they didn't provide a dataset. So here, if I look into this dataset, so I have taken a lot of information. For example, carting FTL. So what is the distance to destination? Then what is the delivery time distribution with respect to route? So different type of information we are having. So FTL, carting. So all those we have created and plotted those graphs. So in which states, right, the number of trips are more, or in which states the number of trips are less, number of carting route. So based on those, right, based on the logistic requirement, I have plotted different type of data. What is the route efficiency in different parts, what is the distribution and efficient route by day, week, all those information. For example, what is the actual time during the peak hours, what is the delivery time, and all those requirements we have added, and we have done a EDA or analysis based on that, and we have plotted those graphs. Not only that, I have done some interpretation analysis based on those information and plotted graph based on what is the trip duration, what is the trip distance, what are the average distance. So based on that, right, our logistic partner, we can fine tune our logistics so that he would be able to deliver these goods in a proper time. And also demand, how demand is getting influenced, right? If our trip are completed very smoothly or in a less amount of time, automatically our requirement for larger amount of logistic partner is going to reduce. So it is very important for us to ensure there is an efficient delivery mechanism also, and for that I have created this model. So that's all. And in the next section we are going to understand our B2B Mart application, so from where we are going to collect all the data. Here is our demo application B2B Mart. Let us log into the application. We have given username. We can also create our own account. Let me sign in. Once you have signed in, we can sort the products, we can view the products, we can sort products from low to high, from high to low. We can also choose on the basis of brands, on the basis of types, and we can also search our products. We can view our products, we can add our products to the cart. We have, as of now, we have created 2 products in our cart. We can increase the quantity or remove the products. Once we have done that, we can click on proceed to checkout. We can again view our products and whatever products that we have, the total billing and shipping handling. Let us click on checkout. Here we can add the shipping address. Let us add Kolkata. Is it an home or a residential address? And the country, of course. We can set it as default address. Go to delivery. On which type of delivery method do you want to use? We can also review our products and we have to provide the payment. So for this we have used Stripe. So we have to write the name on the card. We can open our stripe.com website. Let us go sign into our website to see all the payment intent that has been made. We have also used webhooks to register our payments. So we can give an dummy card number and we can give the month and our CVV. Click on submit order. Our product is confirmed, and if we go to our website and click on refresh, we can see the product amount is succeeded. That's all for this dummy application. We have used Kong API Gateway to manage our APIs and add security, rate limiting, and all the other things, and to create a single point entry which acts or which sits between our server and the client. Then we have used OpenTelemetry to collect metrics, logs, and traces data. Then Zepkins and Grafana for distributed tracing monitoring analytics, and also ELK stack for data search, analysis, and visualizations on the API. This is our Kong API gateway. Here we have added our services, routes, and various plugins along with the consumers. Here we have added a distributed tracing called Zepkins. So let me, if I open one of them, so here I'm going to get all the information, how this API is performing, what is its speed, and all the other data. Here we have used Kong request latency. So here we are getting right in Prometheus, we're getting all the API requests that have been hit. And now we have used Grafana dashboard to see how our APIs are performing. Let me refresh it. So here you're able to see how our APIs are performing: total request per second, RPS route by status code, different latencies, total bandwidth we are sending, and all the other information like Nginx controller, total connections, and all the other accepted values are coming here. Then we have used our Elasticsearch dashboard to see all the API endpoints that are getting hit, which API endpoint, what is the response time, how can we improve our API, and also in case if you want to debug it, we can do all of these things. So let me save it. Let me click on save. Once we have done that, we can go to our discover. Here we are going to see all the API endpoints that have been hit. So if I want to see in case there is some debugging that needs to be done, we can do all of those things through this help of Kibana dashboard.